Welcome to this comprehensive tutorial on using Apache Phoenix for SQL on HBase. Today, we will dive into the concept of Apache Phoenix, how it integrates with HBase, and how we can use it effectively for our big data applications. Let's start with a brief overview of what Apache Phoenix is. Apache Phoenix is an open-source framework that allows you to run SQL-like queries on top of HBase. What this means is that even though HBase is a NoSQL database, Phoenix provides a way for you to interact with it using familiar SQL syntax. Before we begin coding, make sure you have HBase and Apache Phoenix installed on your system. In this tutorial, we will be using Apache Phoenix version 5.1.0 and HBase 2.4.5. You should also have Java and Maven installed as well. First, let's set up a Maven project. Create a new Maven project and add the dependency for Apache Phoenix in your pom.xml. This will allow us to work with Phoenix in our Java application. Once you have the dependency added, the next step is to configure the HBase connection. You can do this by creating a hbase-site.xml file in the resources directory of your Maven project. This file should contain the necessary configurations to connect to your HBase instance. Having set up the HBase configurations, we are now ready to write some code. First, we will establish a connection to HBase using the Phoenix driver. We will need to import the required classes. Running this code establishes a connection to the HBase instance using Apache Phoenix through JDBC. Make sure your HBase instance is up and running before executing this code. Now that we have a connection, let's create a table in HBase through Phoenix. We'll execute a simple SQL statement to create a new table. Phoenix allows us to define the schema in a SQL style, which is a significant advantage if you're coming from a traditional RDBMS background. Once we run this code, we can verify in HBase that our table has been created. It's essential to remember that in Phoenix, every table requires a primary key, which is a bit different from traditional SQL databases. Now, let's move on to inserting data into this table. The upsert command is very powerful as it allows you to either insert a new row or update it if it already exists. This is particularly useful when dealing with large datasets where you want to maintain updated records without duplicating entries. After inserting the data, let's retrieve it using a simple SQL select statement. This will show us how Phoenix queries work, just like standard SQL. The result of this query will output all the records from the users table. As you can see, Apache Phoenix makes it straightforward to use SQL for querying an HBase dataset, significantly simplifying the interaction with NoSQL systems. Let's explore a bit deeper on how to interact with more complex data types. Phoenix supports various data types, including array, map, and JSON. We can define a table that contains these types and learn how to manipulate them. In this example, we have created a products table with a map column for attributes. This allows us to store additional key value pairs related to each product. Now we can insert data into our products table, including the attributes column using the following upsert command. When inserting data into the attributes map, we can use JSON-like notation. This enables flexibility when adding attributes without modifying the schema of our database. Next, let's retrieve and manipulate the data from our products table. We will select the data and process the attribute map. You can see how easy it is to pull complex data from HBase using Phoenix's SQL syntax. This functionality allows developers to maintain robust applications while leveraging the scalability of HBase. Now, let's discuss indexing in Apache Phoenix. Indexing is critical for performance, especially when querying large datasets. Phoenix offers both primary and secondary indexing. Creating an index is as simple as running a SQL statement. Secondary indexes significantly enhance search capabilities, allowing you to query based on non-primary key columns efficiently. Now we can try querying the user's table based on the index name column. This would be optimized due to the index we have just created. As demonstrated, querying with indexes can drastically improve performance. In large datasets, this can make a significant difference in execution time. Let's tackle some of the best practices when working with Apache Phoenix. First, be mindful of how you structure your tables and indexes. Proper design can reduce redundancy and improve query performance. Another best practice is to utilize batched writes and reads when working with large volumes of data. Phoenix performs better with bulk operations, which can significantly reduce the overhead associated with multiple small transactions. Additionally, using the appropriate data types can significantly affect performance. Always evaluate your needs and choose the correct type that balances performance and storage. Now that we've covered some best practices, let's wrap up what we've learned today. We have explored how to set up Apache Phoenix and connect it to HBase, created tables, inserted and queried data, and learned about indexing and best practices. We hope this tutorial has provided you with a comprehensive understanding of using Apache Phoenix for SQL on HBase. With today's project, you can implement Phoenix in your applications, making the most out of HBase's capabilities while utilizing SQL. Don't forget to like, subscribe, and hit the notification bell for more tutorials like this. If you have any questions or feedback, leave a comment below. Happy coding!